Lesson 9-2, solving quadratic equations by graphing. Our objective today is to solve quadratic equations by graphing and also estimate solutions by graphing. We're covering Standard Algebra 1 6.8 and 8.1. When we are graphing quadratic equations, there are three possibilities that could happen. Before we get to them, I want to kind of do a little background of quadratic equations and solving. Back in Chapter 8, we had quadratic equations that looked like this. X squared plus 2x minus 8 equals 0. And in Chapter 8, two things. First of all, it had to equal 0. And at that point, we factored. Do you remember this? Factoring them. And once you got it factored, you set each factor equal to 0, and you got your answers. All right, so that's probably the best way to solve a quadratic if it works out. But in Chapter 9, we're going to learn three different ways to solve quadratic equations. And this first one today is solving by graphing. Now this whole 0 part is really, really important. So in solving these, in the directions, they could be given to you different ways. It could be solve. It could be find the solutions. It could say find the roots, or find the zeros. You know what? The zeros is the most telling because notice how those had to equal 0. We're going to figure out today where the 0 factors in with these graphs. So if you're given any of these directions, basically they mean the same thing. You figure out the solution to these quadratic equations. All right. Now back to the graphing part. Where the parabola sits on the graph determines how many solutions there are. So if it crosses in two places, that means that there are two real solutions. Let's think about this for just 1 minute. Where that's crossing, this is the x-axis, right? What's the value of y at the x-axis?
0.
See where that is? It's basically finding what's called the zeros. Where y is 0, just like in our equation, where y is 0, that's where the solutions are. So back to this, if there's two spots, there's two solutions. This one is kind of weird. It touches just in this one spot right here. And it says one solution, but what did I tell you about equations that have a degree of 2? What did I tell you about that? There's two answers. So the crazy thing is, when you look at it, you're really only going to answer one answer. But it's because it's the same answer twice. So if I did this, let's say that's at a 3, kind of an uneven marking there. You would say that the answer here is 3. But that would come from an equation that was maybe like this. Do you remember some that came out to the same factor twice? And when you solved it, it's the same answer twice. So honestly, there are two, but it's the same answer twice. So you only say it once. Over here, let's go back to this one. Let's say that it would be this. On this one, you'd say your two answers are -2 and 3. All right, on this last one, where's it cross the x-axis? It doesn't cross it. So there's no solution or empty set. Yeah, that makes it really cut and dry and simple. Okay, any questions on how you can tell how many solutions there are. All right, so the whole point of this we did yesterday is we figured out all the parts to actually graphing, and then we went from there and we're going to find the solutions. All right, so for this first example, I substituted in an equation x squared plus 4x plus 3 equals 0, and to find the solutions, we're going to graph it. I substituted this in so that it would have an axis of symmetry that is an integer, because I didn't want to start off with one that was fractional. All right, so as we began yesterday, we should start off by writing what A, B, and C are. So what is A? 1. What is B? 4. And what is C? 3. After you number A, B, and C, you go ahead and work on your axis of symmetry. So I told you yesterday you have to memorize this. What is the what do you have to memorize, Charlie?
B over 2A.
Not quite. It's not just B over 2A.
No, negative B.
Yes. Okay. Negative B over 2A. Oh, sorry. I didn't know that. Negative B over 2A. So if B is 4, negative B is negative 4 over 2 times 1. Negative 4 over 2, what's my axis of symmetry? Negative 2. So I'm going to come over here to negative 2 and dash in a line. That's my axis of symmetry. I'm going to go ahead and work on my vertex. I already have half of my vertex solved for. Which half? The x. So I already know that this vertex is going to end up being on that axis of symmetry. Now, how can I find the matching y? Carly.
Plug in negative 2 for x.
Plug in negative 2 for x in this equation. So it's going to be negative 2 squared plus 4 times negative 2 plus 3. And solve that. So negative 2 squared is 4 minus 8 plus 3. What's that going to be?
7.
Cole. Negative 1. Negative 1. So on the graph, negative 2, negative 1, there is the vertex. Looking at your information, is this parabola facing up or down?
Up.
Up, because A is positive. All right, the next obvious thing is the y-intercept. How do I figure out what my y-intercept is? MJ.
The number that's at the end.
Which is?
3.
3. So this is definitely going to cross at y at 3. So right here. And once you're given 1 point, don't you get a freebie on the other side since it's symmetrical? So if it's 2 units right up at 3, you'd go 2 units left up at 3. So we've got a free point. At this point, we can't avoid it any longer. We have to do a little bit of a table of values. This one we get by really easy. So what you have to do is you have to figure out x coordinates that you want to try to plug in the equation to find the matching y that helps you kind of round out where that parabola is going. And I'm going to tell you right now, this one, we know about x at negative 2. And we know where x is 0. So the obvious point to try would be where x is negative 1. we need to figure out where this thing is going to cross. Okay, hold on. Let me come up there. We need to figure out where this is going to cross the x-axis. We need to know where it's going to cross there, right? And we know it's coming from here and going to go up to here, right? We just don't know exactly what number. So it's at -2 right here. We know have a point there. And we also have a point where x is 0, don't we? So what's right in between those two?
-1.
So that's why -1 is my obvious choice to try. If I can figure out where it is, I can probably figure out where it's going to cross the x-axis. So you just have to kind of go with the information you have. You want to go to the left or right of the axis of symmetry. If there's space between the axis of symmetry and the y-intercept, then you definitely want to try those numbers. Okay, that's how you tell what numbers to plug in. So if I put -1, I got to put it into this equation. I'm going to do it down here. So it's going to be -1 squared plus 4 times -1 plus 3. -1 squared, -1 times -1 is 1. 4 times -1 is -4 plus 3. What is that?
0.
We lucked out because that means that I've got a point right here. And then what's my freebie? 1 unit right, it's at 0.
And 1 unit left.
So 1 unit left. And that is enough to actually sketch my parabola. So here we go. But the best part of all is they fell on corners. They're on integers at the x-axis. What are the two integers that it crosses for the x-axis? What are they? -1 and -3 and -1 would be my two solutions. All right, after we have this graphed, I do want to talk about a couple things. Let's discuss domain and range. So we talked about yesterday, let me go ahead and erase this. Hold on just a second.